Hello everyone, I am so glad to welcome all of you to watch my video. First of all, let me introduce myself. My name is Farah Wardeena and today we are gonna learn about Haber Process. Before we start, let me ask you one simple question. Did your mom ever ask you to do the house chores, or you volunteering to do them because you love it? If yes, have you ever wondered about the substance that you have used to do the job? For example, detergent or dishwashing. All the substances that were used actually consist of one similar compound, which is ammonia, NH3. Now you might be wondering, what is ammonia actually? Ammonia is an amidase inhibitor and neurotoxic that is made up of a single nitrogen atom covalently linked to 3 hydrogen atoms. This is the structure of ammonia molecule. It has a trigonal pyramidal molecular geometry where 3 hydrogen atoms bonds covalently with 1 nitrogen atom. The bond angle in the molecule of ammonia is 107 degrees. As I said before, ammonia is formed from 3 atoms of hydrogen and 1 atom of nitrogen. The atomic number of hydrogen is 1 with electronic configuration 1s1, which means that hydrogen has 1 valence electron. Meanwhile, the atomic number of nitrogen is 7 with electronic configuration He2s2 2p3. This showing that nitrogen have 5 valence electrons. So, hydrogen needs 1 more electron to complete its duplet and nitrogen needs 3 more electrons to complete its octet. Hence, 3 hydrogen atoms and each share their 1 electron with nitrogen atoms to form 3 covalent bonds, leaving 2 lone pair electrons in nitrogen atom, since both are nonmetal and make an ammonia molecule NH3. Now, we are done with the formation of ammonia molecule. Next, we will study with the making of ammonia in industry scale, which is known as Haber process or Haber-Bosch process. Haber process is a chemical reaction combining nitrogen gas and hydrogen gas to form ammonia. This is the chemical reaction of nitrogen and hydrogen, where we can see that 3 moles of hydrogen gas and 1 mole of nitrogen gas needed to form 2 mole of ammonia. This reaction is considered exothermic since it releases 92.4 kJ per mole of energy. There are 4 important key points when we discuss about Haber process, which are catalyst, pressure, temperature, and recycling. The catalyst used in this process is iron with 200 atmosphere pressure at about 400 until 450 degrees Celsius. This process is a reversible reaction because the unused gases will be recycled back in the process. Since we know that ammonia is commonly used in our daily life, we need to produce ammonia in a large amount. Of course, it costs a lot of money, but there are few alternatives that have been introduced by our ancient in order to lowering the cost of producing ammonia. This process is developed in World War I between 1914 until 1918 by Fritz Haber and Karl Bosch. Fritz Haber proposed the use of a high-pressure reaction technique for synthesis of ammonia from its element. Meanwhile, Karl Bosch developed the Haber's demonstration using high-pressure methods, making the process works on large industrial scale. There is one more person who contributed to this process, whose name is Gerard Erdt. He developed the detailed molecular mechanism of the catalytic synthesis of ammonia over iron. All 3 of them contributed a lot in this Haber process and were awarded with Nobel Prizes. This is the demonstration of how the ammonia is produced in industrial scale. I will show you the detailed process of this Haber process. Before we start, we will need nitrogen gas and hydrogen gas. Hydrogen is obtained from the reaction between methane and steam, where it will produce hydrogen gas and carbon monoxide as the byproduct. The hydrogen produced will also react with oxygen from air, forming water and leaving nitrogen behind. Since nitrogen is also one of the components in air, we already obtained nitrogen for our process. These gases then were compressed in the compressor with 200 atmosphere of pressure and delivered to the reactor where ammonia is produced. These gases are then cooled down and ammonia is ready to be tapped off as liquid. Unused hydrogen and nitrogen are recycled back to the reactor and the reaction will continue as usual since this process is reversible. This process is applying the Chatillon's principle where the production of ammonia is maximized while keeping the operating and production cost is minimized. This principle states that increasing the pressure will favor the site with fewer moles, which is in this case is ammonia. That's why a compromise pressure, which is 200 atmosphere, is used. A compromise temperature is also used to ensure that the reaction proceeds with sufficient yield. The temperature is not too low or too high, make it easy to reach equilibrium. As a conclusion, Haber process is a process where ammonia is produced in a compromised condition where maximum ammonia is produced while keeping the production cost in minimum range. Thank you for watching.